Yeah, when we do the quadratic, we'll be looking at ax squared plus bx plus c. But like last trimester, when I had you solve an equation, it was bx plus 2 equals 7, right? And we drew that line down the equal sign. You can see on the whiteboard up there, my geometry class did an equation today. We drew that line and we did whatever we did to one side, we did to the other. So with quadratics, when I have a y equals ax squared plus bx plus c, I can't solve it quite the same. Okay? Let's take a look at this first graph. This first graph represents our graph we did yesterday. If you were here yesterday, it should be the same exact graph as this one actually. I just recopied it over. Okay, so it's this equation here, y equals negative x squared. Minus 6x minus 8. Okay, so what we're going to be doing is we're going to be plugging in numbers for this y. And we're going to be finding out when that y is a certain number, what is that x? Okay. The first one, let's do negative 3 equals negative x squared minus 6x minus 8. So my first question is, could I draw a line down this equal sign and do stuff to both sides? I could start by adding 8 and adding 8. But then what would I have to do? Can I combine this x squared and negative 6x? No. So because there's two different terms with that x and one has a squared, we can't just solve it like we normally solve it. So this unit is really about finding different ways to solve this equation. And we're going to have 3 big ways to do it. One way is by graphing, and that's what these 3 lessons have been leading up to. So you would graph this, x squared minus 6x minus 8. We have that graph right here. It's that parabola. It's upside down. Okay? And we're going to look at that y. What is our y in this equation here? Negative 3. When I look at y, though, on a graph, where would I find that y? Yeah, which one is the y-axis? Up and down. So I'm going to use that highlighter to show that up and down that y. So in this first one here, I'm going to be looking at this negative 3. And I'm looking at that negative 3 as an output or as a y. So on that y-axis, I want to find negative 3. And I know it's not labeled, so we're going to have to think up and down and how many. So as negative 3 on that y, am I going to be going up or down?
Down.
Down how many? 3. 1, 2, 3. And I'm going to look at all the negative 3 for the y. So I'm going to actually do a horizontal line at that line. And that's why I'm using color today. It's going to be really helpful to see that. Okay. So maybe take a second, grab those colored pencils. It's going to be really, really helpful. And what our goal is here is we want to know which ordered pairs on our graph have something negative 3. And I want to know what are the x's that are the ordered pairs on that graph that have a y of negative 3. So on our parabola, how many points go through that pink line at negative 3? 2. So this one is going to have 2 solutions. There's 2 answers. All right, if I look at this first point here, I know that the y is negative 3. I want to know what is the x. What's up? Yeah, they're right behind you. Okay, y is negative 3. I want to know what is the x at that ordered pair. How many left did I have to go? 5. Yeah, so negative 5, negative 3. So our first answer would be x is negative 5, because that's the x of that ordered pair. But we said it has 2 points there. So x could be negative 5, or in this point here, what is my x in that point? negative 1. It's negative 1, negative 3. Which makes sense. On our table, were there times where we had two different x's but the same number? Yeah. If we go back to that table real quick, remember we wanted to know when is the y negative 3. If I look at my table, when was our y negative 3? At negative 5, we had a negative 3 and a negative 1. Because remember, this is the same problem. Okay? Alright, then we're going to do one more on this one. We're going to say 0 equals negative x squared minus 6x minus 8. So we would have graphed this first. We would have taken time to graph it, which we graphed it yesterday. But we want to leave those notes as yesterday's notes so that we don't screw them all up. And this time, what do I want my output to be? What do I want it to equal? What do I want my y to equal? So when we do our output in the function, our y comes first. It says y equals. We have that number equals. So here we have like negative 3 was our y we were looking for. What's our y this time? 0. So I want to find 0 on my graph, on my y, and figure out how many points have a y of 0. So where am I going to find 0 on the y-axis? Yeah, it's actually right at, do I move up or down for 0? Nope. So I'm just going to move across at that x-axis, actually. And that's where that 0 is. Okay, that's where y equals 0. How many times does that touch the graph? 2. 2 times. So there are going to be 2 solutions. When we solve an equation, we're looking for the answer for our x's. What are the inputs? And because there's 2 solutions, I'm going to write x equals, I'll leave a little space, or x equals. And I know I'm going to have 2 separate solutions here. Hi, Miss Snyder.
Hi, sorry.
Everyone say hi, Miss Snyder.
Hi, Miss Snyder.
Hi, I'm the weird person who responds to your messages and stuff sometimes.
Hi, weird person that responds to our messages and other stuff sometimes. Bye, weird person that responds to our messages and other stuff sometimes. Bye. Alright. She teaches with me in the morning. Maybe someday I'll be lucky enough to have her as a teacher. She's amazing. Alright, at this blue line, how many times does it, we said touch twice, sorry. So we need to find the x's. Here's my origin. So what is my first x there? Positive or negative? Negative 2, because I went left 2. And what's my other one? Negative 4. So we don't have to draw a line down that equal sign, do things to both sides. We could look at that graph and look at our input and our output, and we're looking for what is our input when our output is 0. All right, we have one more example here that we're going to do. We have 3 parts we're going to do with this example, so it's really 3 examples, but all with one graph. Okay. Again, I'm going to color code. That's why I have 3 colors today. I'm using brown, blue, and pink. All right, this one we have y equals 2x squared minus 8x plus 6. Now, if we were starting from scratch, we would take our time, figure out what is our A, our B, our C. We would find that vertex. We would make a table, and then we would plot that graph. Okay? But today we're not focused necessarily on making that graph. We're going to use the graph now to find answers to solve. Okay? So for our first example here, we have 2x squared minus 8x plus 6 equals negative 2. So our output this time, it's on the right side. Is that okay that we said equals negative 2 instead of negative 2 equals?
Yeah.
That's the same thing. We normally like to see it on this right side. That's where you're going to see it in your practice. So you'll see an equation. That equation will be graphed, and then you're going to have your output. That's what we're looking for. For our output, where on my graph am I going to look? At -2, but like what does that -2 represent on a coordinate plane?
The y-axis.
The y. Yeah, the y is -2. So I like to highlight that y. It brings my attention to that y every time. So on that y, I'm going to look for -2. From the origin, -2 is up 2 or down 2?
Down 2.
Down 2. 1, 2.
Look what's on it.
This time, how many solutions do we have? How many ordered pairs land on that line? Just one. So there is only one solution. So we're only going to get one x because there's only one answer is what we're saying. Because it only touches the graph one time, what's that one special point that touches that line? What do we call that point specifically?
The vortex.
Not the vortex. Vertex.
Vortex, whatever.
Same thing. Yeah, you got it. Vortex is like a swirling vortex of like madness. Vertex is like the peak. Yep. Or the valley. All right. So we want to find out what is our x at this point. So I can follow it up on your practice. It'll be nice because there'll actually be numbers here, so you can follow that up.
2.
And you can think it's 1, 2. So x equals 2. Perfect.
I'm sorry.
For that one. All right, we got 2 more that we're going to do with this example, just because it's a nice example to do. We have 2x squared minus 8x plus -6. Not -6, just 6, right? Sorry, plus 6 equals -4. So we're going to look for that -4. That's what it equals. That's our output. So from my origin, how will I get to -4?
Down 4.
Down 4. 1, 2, 3, 4. We're looking for how many ordered pairs does this brown line, because I did brown, how many ordered pairs does that brown line go through that's on the parabola?
0.
What?
0.
What do you mean 0?
There's no ordered pair.
Would there eventually be an ordered pair on that line?
No.
No, because where does our graph go eventually? On and on.
Up.
Yeah, it goes up and up and up. So it's never going to go below that vertex. So what we say here is we say there are no real solutions. That word real is going to be really important. And the reason why to Algebra 2, you're going to learn about imaginary numbers, which aren't really imaginary, but they're kind of imaginary, and then whoever named them imaginary, but like they're real because like we work with them, but they're imaginary. It's all sorts of everything. Eventually, you're going to find an imaginary ordered pair on that line that works, but you can't see it, which makes it imaginary. But it's real. It's actually there. It's just imaginary. Doesn't Algebra 2 sound like fun?
No.
Cool. This year, we can just say, nah, there's nothing. Done. Is that okay?
Yes.
Sonia looks very scared. She's going to cry. You got 2 years. You got time. You'll be okay. All right. Last one. 2x squared minus 8x plus 6 equals 6. Try that one out if you feel like you got this. See if you can figure out where you're looking. Alright, so what is our output? What number are we going to look for?
6.
This 6?
No.
No. This 6. Tried tricking you. You're too smart. Alright, this 6. So where on my graph will I find that 6?
Up 6.
Up 6 at the top. 1, 2, 3, 4, 5. Whoop. There was a 6 there. We're just going to pretend it's right here, okay? Alright, so Chloe, how many solutions will we have for this one? 2. How did you know? There's 2 dots on the pink line. Beautiful. Thank you. 2 solutions. So when we do the 2 solutions, we're going to have an x equals or x equals. We'll have two x's. Okay? Naima, do you got one of the x's for us? You don't have either one yet?
0.
0? Says Michael. How'd you get 0? Which one was it? The one on the left or the one on the right?
Left.
Yeah, this one. This one is right on that y-axis. So did we have to go left or right at all? Nope. So it'd be 0, 6. What about this one? What would that ordered pair be? 4, 6. Yep. So when I put 4 in, I get out 6. So it's about finding where it is on your output, your y, and then matching it up with your x's, your inputs, those ordered pairs on the parabola. All right, there is a quick check today. It's going to look a little bit longer, but the questions are really just like this, where it's like, okay, it equals